Second Dance RV Adventures presents solar inverter installation made super simple, or how to avoid this kind of wiring and keep it clean like this.
Hi, I'm Brad with Second Dance RV Adventures. You're getting a video tour of our new Grand Design Solitude 375 RES fifth wheel that we call Second Dance. And she's going to be available for rent in the Central Coast area, primarily Pismo Beach and Avila, which is the video that you're seeing right now. And this is the overflow camping in Avila Beach that has no hookups. So I wanted to be able to rent this out and use it dry camping. So I went through the process of looking at solar and battery banks and inverters, converters, and all of that. And I found that there was just a ton of information out there, but most of them were really pretty complicated and expensive. So I wanted to find a way to keep the price down and the reliability and the functionality up. And I think we've really hit the mark with what I'm going to be showing you here. So this video will take you through the installation that I have so far, which is a solar system tied into a 3,000 watt inverter, which is a combination inverter, converter, battery charger, and solar MPPT charger. Because all those functions are combined in one unit, the wiring is much simpler, and I'll go into much detail in the video as you go forward to see how we got everything installed, and also show you its functionality and what can be run off of the inverter, which is the entertainment system like the TV that you see popping up there, which is a 50-inch TV, and we're going to be installing as well subwoofers and some additional audio equipment to enhance the sound of the AV system. It's functional right now, but I'll do a video once I've got that added in. And you see, like right now, the vacuum cleaner is built into the unit, and the inverter battery bank does run the built-in vacuum cleaner. So anyway, continue to watch the video and see all the details. It's going to be quite detailed and technical. So you may want to watch it over and over again. If you have any questions or comments, please enter them, send us a note, or check our site on rvshare.com and see what the availability of Second Dance is for your next trip to the Central Coast of California between Morro Bay and Pismo Beach. Anyway, looking forward to meeting you, and I hope you enjoy the video.
Part one of the solar inverter installation is the front bay, and as you see, we're approaching it coming up here. And I've got a yellow stick that I'm pointing out different things. This is the Must Solar inverter that I purchased from fuelzero.com, and it was a great buy. And you'll see here in a second the diagram that shows how it's connected. You can get this on their website as well, so you can look at it in more detail and peruse it. You'll also, as I go forward, you'll see that it's actually running right now. I've got it hooked up to a battery bank in the right, which is you'll see in just a minute. As far as the installation of the unit, you'll see I have a 2-foot by 4-foot plywood that I wanted to mount it on, and I wanted to keep the attachment and the holes minimized in the actual RV itself. So I attached 2 L brackets, one here and then also one that's behind the battery box. I drilled holes and put flathead screws that hold the three on each side. And I have not attached it to the bottom, at least not as of yet. I do have at the top three screws, one here, and one just off the screen that I drilled pilot holes in, and it's screwed in at the top and held up at the top. This unit is 60 to 65 pounds, so I wanted to make sure that it was strong enough. The wall that was there, I think, was a little too flimsy to hold the 65 pounds, so I got thicker plywood to attach it to. And then also the battery box itself is holding it up as well. And you can see at the bottom there, I'm going to go back just a second here. You'll see on the bottom that I have not attached the L brackets. I have some L brackets I'm going to screw into the bottom and hold the battery box back. I have not attached those yet, so for the time being I'm using just a pad, a plastic pad that fits just perfectly to hold it in place. This battery box, I looked all over, and Tractor Supply Company was the place that I found something that would actually work for this. So I was really happy to find a box that actually fit for 6-volt RV batteries. Now these are wired in series parallel. You'll see these two batteries here are connected, the one positive to the negative, and so I had these wires marked with the stripes to indicate that it goes between positive and negative, and that creates one 12-volt battery here, and then there's another two 6-volt batteries that are connected with this cable. I'll put a link into the company. I took the measurements that I needed and ordered these cables from, I think it was Cable USA or USA Battery Cable, something like that. I'll put the link in the description. And I just put in the lengths and ordered them, and boom, they came in the mail. It was really great, well-produced product, and I'm really happy with it. I didn't have to make my own cables and create the the crimping and everything. Now, the only thing about this battery box is there was a bit of space in the front and the back that the batteries might be able to slide back and forth in. So I simply bought 4T elbows from Home Depot, PVC pipes, and place those in, and they're fit nice and snug and hold the batteries front to back, left to right. They fit perfectly. You see this black cable is actually the black cable, or the negative cable, going out of the box. So I just ran it through there as an additional holding. You see there's one of them, and there's the other one. There's not a cable going through it. Now on the top of the inverter, there's actually the AC is connected right up here, and you'll see that there's actually the AC in. Well, first I will say there's photovoltaic in. So you have, it says PV in, that's photovoltaic. So the solar panels come in, and I've got the negative on white and the positive on black. These are 10 gauge wires that I'm bringing in from the solar panels into the unit itself. Then this is going to be the AC in. I'll go a little further forward. You can see AC in, and you've got these are 2 Romex cables. In other words, it's 6 gauge positive and 6 gauge neutral, and then of course a copper ground. It's the ground goes into the ground connection here, and the positive and neutral go in here. So this is the power that comes in from shore power. You'll see in a minute where that comes from, and then it'll bypass and send that same power back out through another 6 to Romex cable, and you'll see where that's connected later. So the power to charge the batteries comes in from photovoltaic, or it comes in from AC. This will automatically switch charging the batteries based if there's no AC. then the batteries will be charged from the solar. If there's no solar and no AC, obviously if there's AC, then the AC will come in, it'll charge the batteries, and then it automatically just forwards the remaining AC back out to the breaker panel. And keeping the holes to a minimum, you'll see I drilled one hole for the AC coming in and the AC going out through one hole here, and then I've got the photovoltaic coming in, one wrapped up cable here. The other wrapped up cable is actually the control panels for the remote control that's inside the coach itself in the kitchen, and you'll see where that is a little later. And that those control wires come down to the bottom, and you'll see there's actually two control wires, one hooked up here and the other comes in here. The other connections you see in the back, of course, is the negative for the battery and the positive for the battery. There's also a battery temperature sensor, and this wire goes, and I've attached a temperature sensor to the battery bank. This is a connection for a generator, remote start generator. I don't have a generator that has the capability of attaching the remote start, but this will actually, if I had a remote start generator, run a wire from here to it. If the batteries got too low, it would automatically tell the generator to start, and it would recharge the batteries if they weren't getting sufficiently charged by the solar system. You'll also see these dip switches on the bottom. That's a number of different options that are available. One primarily is the priority for grabbing energy coming from the AC or from the batteries, the DC. So you can actually have it pull the electric from the batteries as a primary source, and then when the batteries run low, switch over to AC, or you can have it pull from the AC if it's available first, and then only use the batteries as a backup to AC, and that's the way that I have it set up. And of course, there's several other options. There's like 5 or 6 of those dip switches, which the remote control will tell you. Now, I also, if you notice, have not removed the factory installed battery. It's still in there. I have not removed the the converter, which charges that battery. So I've actually got a battery bank to run the AC, and then the existing house battery still runs the DC power. And the way I've got it set up is if I choose to, I can have the extra battery bank, the golf carts that I ran through the inverter, can be used to actually charge the house battery. That way I minimized having to disconnect that and reconnect everything. And then once again, you can see the cords going into the next compartment, which is part 2. This is the compartment on the right here. You'll see this is a kitchen that slides out, so kind of ignore that, and I'm going to show you how the wiring is on here. You'll first notice that there's a lot of exposed wiring. So what I did is I actually took out the panel. On the left hand side, there's 4 screws. One was at the top, there's one I left in the bottom down there, and then on the right hand side, so you see those other 2 screws there and down here. I have the panel just set aside so we can see in here. Once I'm done with this video, we'll go ahead and reinstall that, and it'll all be hidden away. And so the first thing to do is look for, where does the power come from? Power comes from shore, and so when you plug into the shore power, there's going to be as you see right here, this cable is the incoming shore power. That's actually a 6-3 Romex cable, which means that there's 2 power cords, 2 positive lines, one neutral, and then 1 ground. And it comes around, and I'm trying to point out, it's hard to see, and you'll see it comes back around and goes into the back of the existing breaker box. And so you'll see here in a second the breaker box where it goes in. So the first thing I had to do is remove it from the breaker box, and you'll see right here there's a cable connect or clamp that holds it in place, that keeps the tension from being pulled out from inside the breaker box. these are horrible. This is a plastic one. The only way to remove this is to cut it. So I got some snips and had to cut this plastic wire holder and just remove it completely. And you'll see later I used replaced it with a metal. And this is on the other side. This is that same plastic where it comes in, and you'll see there's 4 cables that come in. Again, you've got the positive on a black, and the power comes in here and then is transferred to all of the switches above it, and then goes out to different sources or different destinations at the bottom. The red comes in here, the power comes in there, that's 50 amps, and then is distributed to all of the units or the switches below, and then comes out of these black cables. So it's important that you know that there's actually 2 legs to a 50 amp service. One goes on the top half, the other covers the bottom half. So those are 2 positive cables. This is a neutral cable, and then there's also you can see behind here, this copper is the ground. So and you'll notice these 3 are very thick there. That's why it's a 6 gauge, very difficult to deal with. Now you'll also notice that on the other side it was black and was wrapped in a black, and that black has been cut off right here. You'll see in a moment that when the manufacturer built this, when they wired it, they took a box cutter or a razor or something and cut that cover off. And the problem that happened is when I pulled those cables out and I ran them into the next cabinet. You see I drilled a hole here. I pulled the cables out of the back, put them underneath the next cabinet, brought them up here, and actually needed to have a longer stretch. So I cut that cover back a little further and discovered that when they initially cut it off up here, their razor blade went through and was exposing the cables. So I saw metal cables and I wrapped a little extra tape around those. I wasn't sure if I had enough length to cut it off right there and just restart from that point. So I wanted to be careful. So I actually just wrapped those cables on there. So what I've done is the power comes in here and goes to the 2, the red and the black, and then again goes to a neutral and ground bus bars. The next step was once I brought this in here, I wanted to take one of these legs, which is going to be the one that is on the bottom, and send it up to the inverter. So the other leg goes straight back to the panel, and was only the top half of the existing panel will only be powered when there's shore power. The bottom half, if the shore power is cut off to the inverter will still supply power to the bottom half of the panel. So now you see what I've done with this is I've actually run the 2 additional cables, because what will happen is the power comes in here and here, and these are the 2 breakers right there. This clip here will come up and clip right onto here, and then the power will go out of there, and since it's on the left hand side, this is the one cable that goes to the input on the inverter that we saw in the initial part 1. The other power will come in here. It'll go from this clip to this clip right there. There we go, to this clip right here, and that's going to go ahead and send the power out here and directly back to the top half of the main panel. And then what you see next is those simply brought up and clipped on, and this is what it looks like when it's actually all in place. And then the next spot is this is what it looks like once it's connected or I've set it back up. And behind this, right on the right hand side, is where the main panel is. You'll see it a little later. So you've got the main power coming in here on 6.3 Romex cable, and then you have 2 6.2 Romex cables coming out of here, one up to the front inverter and the other direct to the main panel top half. So again, this is what the panel looked like originally, and this is what it looked like after I pulled the cable out, ran it up into here, and then the two cables coming in here before I installed them. And now this is what it looks like after it's been completed. So this black is replaced by this black that comes directly from the sub panel that I installed. Then this red is the same as this one, and it comes in from the inverter. So you've got, instead of one neutral, you actually have now two neutrals, one from each of those 6 2 Romex cables. And then instead of one ground right there, we have 2 grounds, one from each of those 6 2. You'll also notice that this original ground was in this connection, and I couldn't get the screw undone, so I clipped it off, and then I used the connection below and below there for the connectors on the ground wires. So that's the, you see that's where the power goes in. That was the back up there. Let me go back again and just show you there's something I missed. One thing you want to notice is you see this bright light under there. That's actually where I could slide the cables up underneath, and that's the kitchen area right below the panel. So that was wide open. It was really convenient for accessing, reaching underneath and getting everything. So now the cables, the 2 Romex, come up underneath here and come up over the top, and you see I have them zip tied and connected to the ceiling of the bay where the kitchen is. And this is the other side, as you saw from the other side. Remember, you have the one cable going into the inverter, the other coming back out. Then there's one cable coming up here that is the remote controls for the unit, and then this is for the solar. And you'll see the solar comes in from a different location. First though, what happens is if we look, I'll point it out another time. I've got this, I didn't want to put any holes in and minimize the effect on the unit, so I have it running out, and you'll see in the next portion where that wire goes. But there's also right on the roof up here of this a label that says solar roof access, and I'll point that out again from the other side. But this is where the solar panels come from on the other side. Now we're in part 3, and you'll probably wonder, why is there a toilet plunger here? And it's actually clean, don't worry about that. It's actually the perfect distance for me to pull out and attach to the side of the RV, because that's how far the slide outs will go. And when we're backing into a spot, if I attach it to the side, it sticks out, and we have a measure. We know if that doesn't hit the power pole or any bushes, then we're far enough away and we can go ahead and open the slide out and it won't hit. So that's just a measuring device for backing in and parking the unit and getting the slide out distance correct. So now you'll notice a couple of things here. I've got these little zip ties were affixed here, but they're not really holding very well, so I'm going to have to reattach this. And you'll notice, like I did up here, I did that on that one, there's actually a hole in the middle. I can take a small wood screw and just wood screw it in to the top to hold it in place and not rely solely on the adhesive that came with that. Also right here where this pipe is coming down, there's a label, and you see in the picture that's coming up, satellite roof access. I can't figure out which hole it is that this access comes down from, but you'll see on the roof there's a panel where the roof access the wires can come up. So somehow it's designed to have a channel up to the roof when I want to install the solar panels on the roof. For right now, I'm avoiding drilling holes in the roof, but when I'm ready, that's going to somehow provide access. I've been looking at Grand Design forums and trying to figure out how to access this, because I'm not really sure which of these holes it is. So look for more information on that as I delve deeper in. And now you'll notice here too that I didn't want to drill holes. I want to get this cable down underneath the RV, and there was I don't want to drill holes, so I simply wrapped it around here into the water bay or the utility bay, and have it going right through where the water comes up, or the cable, or those items. So right now I have just a this is for flushing the black tank. So I shot this video while I was flushing the black tank, and I didn't have the drinking water coming up through there. I had already removed it. And then I ran the cable underneath here and have zip tied it to the propane line, and then I've actually just wrapped it around here, and for traveling purposes, and bungee corded it. I've got a connector to a distribution box for the solar panels, and I also added right in here a 15 amp fuse. So for right now, I love this design of our RV, the 375 RES, because of all the storage in back, and I bought the solar panels from Harbor Freight, and they are 25 watt panels. You get 4 of them for 150 bucks when they're on sale, and so it's and they just stand up and pop up. I'm looking, and this is I've got 2 sets, so I've got 200 watts, and they have combiner wires, and they go into this combiner box, which then plugs underneath. I just throw it underneath and set the panels on the ground. They have stands, or I can leave them on the tray that this is, and it actually slides out, so I don't have to actually have them necessarily installed on the roof. And I can actually, this combiner box will take up to 400 watts, so I may add a couple more for 300 bucks, get 200 more watts on the system, but we haven't. I'm putting that off for the time being. Now we're in part 4, which is the actual testing of the unit, and you'll see the whole layout and the results. Here is the distribution panel with the cover back on. Of course, the wires are not exposed. And right next to it is the sub panel, which I showed you the wiring, the power coming in and the power coming out. And you'll see the power, the main panel, power comes in from the shore, gets broken into 2 power lines. One goes out to the inverter, and the other comes back over to here. So the one that goes to the inverter then comes back into the bottom and powers the bottom, and the other that comes in directly powers the top. Now the sub panel, I've actually put in 30 amp fuses instead of 50 amp, just to be safe, and also the inverter has an input and output fuses of 40 amps, so I thought instead of putting in 50 amp fuses, let's just try 30 and protect everything, and be a little safer for the time being, and we'll see how it works over time. The other thing is you'll see on the bottom, there's the bottom, next to the bottom on the right is I'm going to go back. The second from the bottom is a fuse for the converter. Now, if I don't want to send power from the batteries in the battery bank from the inverter and charge the house battery, I can just flip off the second from the bottom, and that turns off the converter, which charges the standard house battery. So just you'll see something in a minute that gives you an idea what that will save us a little bit. Now you see I have it hooked up to power right now, and there's 2 30 amp fuses, and this is the power cord, or the 2 control cords that come in from the inverter for the remote control, and this is where that white light was underneath, where I can run the wires. I'm considering running those cords, drilling a hole right here and not having it run on the outside, but again, for the time being, I'm holding off on drilling too many holes, and we're going to test it out, and once we're happy and satisfied, we won't have these cables hanging out there. There'll be a hole right there. It'll go through the wall to the bottom and come out in the closet at the bottom, and you won't see as much. Now this is the actual remote control. You see the temperature of the unit is at 6 amp or 6 degrees Celsius. And here's the power from outside is coming in, going through the inverter and charging the battery, and it's also the power is being bypassed to power anything in the unit that is being run by electric. The input from shore is 120 volts at 60 hertz. And we say it's on AC power right now. The output is the same, 120 volts, 60 hertz, because it simply bypasses. The next is that the batteries are at 13.1 volts, and there's 1 amp that it's charging the batteries, so they're pretty much full. This is the unit can charge the batteries up to 70 amps from AC and 40 amps from the solar. Now we're back to the load is at 0 because there's nothing being drawn off of the batteries. So again, we got input 120, 60 hertz. So what I'm going to do now is turn off the input power, and you'll see I flip that switch off just to the left side because that's what runs the battery, and the input drops to 0 volts and 0 hertz. So now you see it's switched from the AC light to the inverter light, and the output is still 120 volts, 60 hertz, and the power, there's no power cord coming in from outside as you see here, but the battery is now going through the inverter and powering any electrical systems. And you see the batteries are at 12.9 volts and they're 100%. Now, of course, it was 13.1 before because they were actually being charged. There was a trickle charge going into them. And now they're just showing what the existing charge is off of the unit. Now we want to test it some more, the batteries. Now the load here, you notice the temperature is 6 and the load is 2%. The reason there's any load at all is because I didn't turn off the converter. So 2% of the power is going to charging the house battery or trickle charging the house battery through the AC panel. If I reached down and turned off that second from bottom switch, that load would turn to 0 because there was nothing else running at the time. But 2%, the unit puts out 3,000 watts, 9,000 peak, but 3,000, so 2% of 3,000 watts, whatever, that's what it's running right now to charge the battery. Now let's go ahead and turn the refrigerator on, and we'll see how much power does the refrigerator take. Once I got the refrigerator turned on, and it's on electric, of course, the load jumps to 25%. So 3,000 watts, 1/4 of that is going to be about 750 watts. There's no input. The output is 120, no input from AC. The battery's at 12.1 volts. And you see the voltage dropping and the percentage changing just because there's that draw. And the load is at 25%. And then when we turn off the refrigerator, you can see that the load drops from 22 down to 2%, which again is the converter. Now we'll turn on the vacuum cleaner. It's a built-in vacuum cleaner. You can hear that running, and the load jumps from 2% up to 52%. So about 1,500 watts is what the vacuum cleaner will take. And I turn off the vacuum cleaner, it drops, and it goes from 52 down to back to 2% load. And the input again is 0 from shore power. And if I flip the power back on, you'll see that input goes from 0 to 119 volts, 61 hertz. It, shore power does vary slightly. And the output is just a bypass. And you see the power going bypass and it's charging. And it's back on AC power. So there we go. That's the system. And we look forward to having you visit us.